All right. I still hear the mic thing. Oh, nice. We're live anyway. We're having some
Yes. Okay.
weird technical difficulties. But anyway, we'll deal with it. Welcome to another session. Brought Richard today. Richard, what do you have for
Cool.
us?
Yeah. So I've got a little talk about scaling AKS nodes and the new node auto provision. So if you want to chuck my screen up, I can get straight to it.
Let's do it.
Cool. It's a nice new slide deck as well. I created it recently, so hopefully it works well, but we'll see. Technical difficulties with your microphone, could be it with the slides, or the demo gods could be against this as well today. But yeah, so let's go straight into it and we'll introduce myself. So who am I? I'm Richard Hooper, also known as Pixel Robots Online. I'm a principal cloud architect at a company called Intercept, who are based in the Netherlands. I am actually based in the UK, as you could probably tell from my accent. I'm a Microsoft MVP and a Microsoft MCT, so trainer as well as sort of advocate for Microsoft products. You can find me on Twitter or X. I should probably change this slide to say X at pixel_robots. And I blog on pixelrobots.co.uk all about AKS and other bits and pieces to do with the cloud native world. So the agenda today, just 3 sections, trying to keep it nice and easy. First off, we're going to talk about the Kubernetes scheduler. Next, we'll talk about the Kubernetes cluster autoscaler. And then third, the bit everyone's probably wanting to see, and that's the AKS node auto provision, or NAP for short. So this is a cool slide. I really like this one. All the images are generated with ChatGPT and Dwali or whatever the thing is. So this is all about the Kubernetes scheduler. What is the Kubernetes scheduler? Well, it's a component of Kubernetes that assigns newly created pods to the most suitable nodes, and it does that based on a few bits of criteria, which we'll go into on the next slide. It also uses objects requests to like allocate the pods and stuff like that. So it's quite cool like that. Yeah. Then it also uses the kube scheduler. Well, we're talking about the kube scheduler. It's actually the default scheduler inside Kubernetes. You can actually have multiple schedulers as well. In AKS, you can actually only have one currently. Hopefully, maybe soon we'll have more. Outside of AKS, you can swap the scheduler as well. So even though kube scheduler is the actual default one, you can actually use different ones. One thing the kube scheduler, the Kubernetes scheduler, doesn't do is reschedule your pod. So it won't go, right, we've got this node over here. We can move this pod over to that node and actually bin pack it better. So we'll do that. It doesn't do that. So to definitely keep that in mind when you're thinking about the Kubernetes scheduler. These scheduling details that we talked about in the first slide, the criteria it looks at when it's scheduling a pod is the resource quotas, so like your requests and limits and stuff like that. The taints and tolerations, so you can actually taint a node to say, I can only have, say, critical add-ons only or critical services only. And then my pod manifest, my deployment manifest needs to stay in that manifest. I tolerate that taint and I'm okay to live on a node with that taint. Then we have the selectors and affinity. So selectors are a bit like taints and tolerations, but not as harsh. You can say, I'm happy to go on any node that has this label, for example. So I could have like my workload node pool in AKS, and I could call it a label node type workload, and I can put in my pod manifest, my affinity, my selector, I will go on any nodes with that label. You can do it with Windows, Linux, there's a label for each of those, and you can say, I'll only go on Linux ones, or I'll only go on Windows ones. Really good when you're deploying, say, Nginx ingress controller, and you've got a cluster with Windows and Linux. You need to set your Nginx to say only go to your Linux ones using the selectors. Otherwise, it tries to deploy it to Windows and it just doesn't work very well or come up at all. I've been there when it first came out with the Windows nodes. It was not fun troubleshooting that one. Then we have topology spread. So in Azure, you have this thing called availability zones 1, 2, and 3, which are like data centers with separate cooling power inside an Azure region. This extra section you can put into your Kubernetes manifest file called topology spread constraints will actually help you spread your workload over the different availability zones. So instead of going all on one node in availability zone 1, or even a couple of nodes all in availability zone 1, it will spread it out over the zones you have selected for your node pool. Then it also takes into account the disk dependencies and limitations. So if you have a bit of storage mounted into your pods, and they're using like a locally redundant storage in Azure, and it's mounted to the node itself in that zone, then your pod will try, or the Kubernetes scheduler will try and schedule your pod to that node, because that's the node with the disk attached. So it needs to be able to mount that through. With the zone redundant storage you can get now, it makes that a lot easier. But yeah, that's something you need to be aware of as well. Then we go into the cluster autoscaler, which is a very important component inside your Kubernetes cluster, because without this, your cluster can't scale up the nodes. And so the cluster autoscaler is basically there to automatically add or remove nodes. So if you have, say, 4 nodes in your cluster, and then your deployment, or you have a long running job that stops, and then that node's not needed anymore because all you have running is like your daemon sets, it will scale that node back down, so get rid of it. In AKS you actually have 2 options. You have deallocate nodes or delete nodes. So delete nodes, that node goes. Deallocate, what it does is it takes the storage and it keeps that, and then it will get rid of the sort of virtual machine scale set image, or instance I should say, but that OS disk is still there ready to go. And then when you scale back up, it attaches that OS disk and it scales up within seconds rather than minutes. So that's really cool feature of the cluster autoscaler. It uses, or it's used by horizontal pod autoscaler, so HPA, vertical pod autoscaler. So like a way to increase the CPU and memory of your pod upwards instead of adding a new instance, which happens with the HPA. And then Kida and other autoscalers. So Kida is just a scaler, basically uses external metrics to figure out if your pod needs to add a new replica of it, and then it uses the HPA to create that extra pod for you. But the cluster autoscaler only acts on a few things, and well, basically it acts on when your pod is in pod pending state. So if your current node pools don't have enough resources for your new pod, say you've got a new pod and it needs 1 whole CPU, but all your nodes have got maybe half a CPU free each, well, your pod's not going to scale. So it's going to say, hey, I can't be scheduled. I'm in a pending state waiting. So cluster autoscaler will then go and add a new node for you in your node pool, whatever the same size as your node pool is, and then your pod will get scheduled onto that. When there are underutilized nodes, the cluster autoscaler will scale down. So like when there's only daemon sets running, like I said earlier, it will scale down your nodes back to 3 or 2, or also even 0 if you really want to, because it uses virtual machine scale sets, so you can scale to 0. If you have your system node pool, you can't really scale it down to 0 because you always need a system node to run, but you can stop and start the cluster anyway, so you can shut it down over the weekend or in the evening. It takes a sort of snapshot of your control plane, and then when you start it up, everything is exactly as you had it before. And because it uses virtual machine scale sets, it uses the whole principle of virtual machine scale sets is 1 base OS image, and then every instance of the VMSS, so a virtual machine instance, will be exactly the same. So you have that base image, like your golden image, which Azure creates for you. It's like a VHD file. If it's Linux, you get an update like once a week. If it's Windows, it's like once a month, Patch Tuesday. And yeah, so these new nodes in your node pool in your VMSS use that base image every time a new instance gets created. So with that, let's go and have a look at a little demo, because I'm talking too much and slides are boring. So if I get my VS Code, hopefully that's big enough for everyone to see. If not, we can make it a tiny bit bigger. So I've got the cluster. Yeah. So I've got the cluster AKS CA demo UKS because I'm in the UK. I do everything in UK South because, it's my closest region. I'm in my Microsoft Azure MVP sponsorship, and we'll forget about the AWS logo there because it's just there. I do a bit of AWS, so I'm in this cluster AKS CA demo US. What I'm going to do is paste in a command which is kubectl get nodes. I'm outputting it as JSON, and I'm going to use a bit of JQ to get me the information I want. So I'm getting the name of the node, and then some labels of the instance type, and the sort of node pool type. So if I hit enter here, we can see I got 3 nodes, which are named these names here. I'm not going to say the whole names. They're running standard DS2 V2s, and they are a virtual machine scale set. So we can see there straight away we've got that. Just standard nodes, standard size. These are actually just a system node pool because it's just a demo. We can do that. It makes it fine. Usually you would have your workload and your system, but I'm trying to keep costs down. Next, we have the config map for the cluster autoscaler, and we can check what the status is of it using this command. And we can see that we have it's enabled at the time of here. It was healthy. We had 3 ready, 0 ready. It's just a lot of information about the cluster autoscaler, so you can see if it's enabled or not. It's good to sort of keep an eye on this. This is when you're using the Azure portal and stuff like that, and you're having scaling issues. This is something you can go and check to see what's going on as well. So definitely have a look at that. But it's a bit of a boring demo. We want to sort of see something actually happen, don't we, really? So in my other tab, I'm going to do a kubectl get events, and we're going to select the cluster autoscaler events, and we've got a -w at the end to watch it. So I hit W on that. We'll go back to this one, and what we're going to do, I'm going to create a new namespace called inflate, just because we're going to create some things. I've actually stolen this demo from the node auto provision repository as well, and a bit of help from a guy called Philip, who also did a session like this at a user group.
Is that this Philip?
Yes, it's this one here. So yes, I'm borrowed quite a few of his commands as well. So thanks, Phil. So yeah, we're going to basically just now apply the Kubernetes manifest file, which is called demo in inflate. It's basically, except I don't have it here. Do I not? Am I just in this repository? Yeah, there we go. So this, in fact, let's just cut it out so we can have a little look what it's doing. It's just a basic deployment with 0 replicas, and we've got the labels, and it's just pulling in the Kubernetes pause container image, and we've got requests of 1 CPU and 256 meg of RAM, so like a quarter of a gig of RAM. Very basic one, but we've got none of those running at the moment. So like we can see back here, we still got no scale events. And if we do kubectl get pods in fleet, you can see there's no pods running at all. So what we're going to do next is we're going to use kubectl again, and we're going to scale it to 10 replicas, just like that. And it says it's scaled. So if we hit up again, we can see we've got 10 pods, 2 are running, quite a few are in the pending state. And we can see the cluster autoscaler logs will hopefully pick that up shortly, just like that. And now it's going to say, right, I need to trigger the pod has triggered a scale up of the BMSS, because we need 3 to 10, and I've got a maximum of 10. So it's just going to scale those up for us. And then hopefully shortly, if we check that again, if I've got the right amount of quotas in Azure, because they keep reducing my quota allowance of CPU. I think all this AI is just taking over, and everything's being used by that. But basically, this will start spinning up a new node for us. If we do the node one again, we might see a new one. No, we don't see it yet, but hopefully shortly a new node will come up, and we can see that. But we can always check on that in a bit later as well.
I was about to ask, what is the instance type, but it's on screen now. Standard.
Yeah, it's standard DS2 V2s.
Yeah,
so that's just my node pool size. It's just that. So usually that's normally available inside the region, but yeah, they've just been having quite a few issues lately. So if we just do let's just do kubectl get nodes. Yeah, here we go. We can see some nodes coming up now. Some not ready, some are ready. So at least we're scaling as well. If we do my big query again, there we go. Getting lots here. We've got some, so like the ones that are coming up say null on the instance type because it hasn't got that information yet. And yeah, that's basically telling us it's triggered up. There's no more events there, which is nice. And then if we check the pods again, we can see all of them apart from 2 are currently running. These are now in container creating, so it's pulling the image, setting it all up in the nodes. 1 left, and hopefully very shortly that should be done, which is nice. We can also see if we do like a out wide, we can see that it's all going on all these different nodes. So we've got 5, 8, 7, 3, 9, 0, 6, 4, 1, 2. It's a bit weird out. It's not in order, but yeah.
So we're at 10 nodes now, or
10 nodes, which I think is my limit I've put down. And yeah, maximum of 10 count is the limit, which is what it said in the so it's doing 3 to 10, maximum of 10. So we're at 10 nodes, which is nice. So I do have some quota, which is good. So that's how cluster autoscaler basically works. You know, we've said we started off with 0 pods. I then scaled it to 10. We didn't have enough resources to run all of them. So the cluster autoscaler said, oh, okay, your pods triggered a scale up because it's in a pending state, and I'll go and create you some new nodes. And it's taken a little bit of time to get those nodes, but they're all up and running. We've got 10 of them. And, you know, that was all good. We can then scale it down to, where is that command gone? Where is it? Scale that back down to 0, and then pods will start getting deleted. Already deleted, but the nodes won't get deleted straight away. So if we do the get nodes again, we can still see we've got all 10 already, and that's because the cluster autoscaler's got this profile on it, and that profile is set by default to check like every 10 minutes to see if a node needs to go down or needs to stay up and stuff like that. So these won't actually scale down for like another 10 minutes. We're not going to let everyone watch that, and we'll just keep refreshing 10 minutes, 10 minutes. No one wants to see that, but we will probably come back and see if it scaled it down afterwards, which will be a good demo, I think, as well. So that, yeah, that's the sort of cluster autoscaler side of it. So if we go back to our slides, that one there, and then the next thing is Karpenter, which is basically the node auto provision, but Karpenter's the open source name that people know it of. But what is actual Karpenter? It's not a guy who can't spell, who's dyslexic and can't spell Karpenter, who works with Word. It's actually a cool bit of technology that came out of AWS, actually, back in the day. And it's a sort of equivalent, I guess, to say, to the cluster autoscaler. So it's another sort of autoscaler in a way. But this one is a lot more granular than the cluster autoscaler. What this one does is it basically watches the pods, and then if the Kubernetes scheduler has marked it as unschedulable, so not pending this time, unschedulable, then it will spin up a node for you. It evaluates all the constraints just like the cluster autoscaler did, so like your requests, your selectors, and stuff like that. It provisions the node that meets your requirements of the pod. So in the cluster autoscaler, it just adds a node the same size, you know, DS2v2, whereas NAP or Karpenter actually can go through a list of all your D series VMs, for example, and then pick the one that is required. So instead of having a DS2v2, say my pod had a requirement for 16 cores of CPU because, I don't know, do some AI or something like that. It will look through all of the D series nodes you can get, but then also check my quota in Azure and say, right, you have access to this size, and it will use a D16, say, instead of a D2, you know, because it can't scale up on the D2 with the virtual machine scale sets. That's what it can do, is add another D2. I haven't got a new node pool with a D16 already in it, but Karpenter will go, oh, you need a D16. here's a D16. Happy days. It's all working now, which is really cool. And the cluster autoscaler cannot do that. You have to know what kind of resources you need from the get-go. You need to create your node pools from the get-go with the specific sizes you may need. Yes, you can scale it down to 0, but you still need to know, I need a node pool which is going to have this VM size, and I need a node pool with this VM size, and so forth. But another good thing about Karpenter is it can remove nodes when they're no longer needed, like cluster autoscaler, but it can actually do it. It can sort of reschedule basically, which is really cool. And
But
as I mentioned,
does it create a new node pool for you then?
No. So in AKS it's called a node pool, but it actually just creates a new node, not a node pool at all. It's just a standalone node which is running a VHD, a base OS image of Kubernetes, AKS version of Kubernetes with the stuff it needs. But it is a standalone node. It's just a standard VM, not a VMSS at all, which is really cool. And that's how it can pick the different sizes you need. So that to me is one of the selling points of Karpenter or node auto provision. Is I don't need to know what size VMs I might need from the beginning or at a later date. It will just, I could have a developer go and spin up a new pod. They're testing it out in dev, for example, because I've got governance in production, so they can't do anything. And they set their requests and limits a bit too high, and the current node pool or the current nodes can't work. But instead of then logging a ticket to IT ops to go create a new node pool, Karpenter will just handle that for you, which is awesome. And because it's now open source from AWS, they donated it to the CNCF. It's now part of the SIG autoscaler as well. So it's all open source and lovely like that. So Karpenter on Azure is slightly different to Karpenter on AWS because, one's AWS, one's Azure. On Azure, we actually have 2 versions of it. The self-managed option, which is installed via Helm, and that's from November 2023. That came out around about the time of KubeCon. And then since about January this year, the node auto provision has come live, and that's the AKS managed offering. So like the cluster autoscaler is managed through Azure, so is NAP, which is really good. So you don't have to go and update it, wait for the latest updates. And because it's managed, it actually also installs some resources for you in the cluster, so you don't have to go and configure what they call node pools and stuff like that. It does that for you out of the box. Like we said just before, it doesn't use VMSS. It is just nodes in your Azure subscription. It's just nodes, which is really cool. One thing to be aware of is whatever your Kubernetes version is of your control plane, your master part of AKS, the nodes will use the same version, and they'll keep changing to that version unless you tell it not to. Whereas before with virtual machine scale sets and cluster autoscaler, you had to go and update your control plane and then go and update your nodes, whereas this does it nice and automatic for you.
So So what happens if that specific version of AKS is it deprecated? It's not supported anymore, but I'm still using it because of certain requirements, apps, whatever.
Well,
will it then be able? Yeah, I know.
Hopefully you're on long-term service LTS version of Kubernetes, because you need to be in the last 3 versions of Kubernetes inside AKS to get support. So if you do have this need for a long one, look at long-term service. Hopefully Karpenter will work with that. We don't know yet. They haven't given us any information, so fingers crossed it will, but cluster autoscaler will. But yeah, only on the LTS. Don't try and run, say, 1.22 still in production, because you're not going to get any support at all, and you'll find that it probably won't start to scale soon as well. Always keep up to date. The last 3 versions. So we've got technically 1.28, 1.27, and 1.26 are live in GA. 1.29 is in preview. When 1.29 goes GA, then 1.26 will be end of life. So yeah, just keep an eye on that.
All right. So Philip added something, yeah.
Yeah, that's literally the next point I was getting to. So the the actual node image itself as well, not just the Kubernetes version, but the node image will get updated with the drift detection, just as Philip said. So thanks, Phil, for that. Awesome. I love this. If he's got any other things he wants to share, because he has been looking into this feature quite a lot, feel free, Phil. And yeah, as we mentioned before, it's all open source, so anyone can contribute. You can go to the Karpenter core Git repository and check things there. But then the actual Azure part has been open source as well. So the Azure provider for Karpenter has, you can go check that out, do issues, pull requests, get involved with the community, which is really good. And with that, I think it's another demo time because, yeah, slides, no one wants slides really. So we go back to here and then we switch to my other cluster, which I have made previously because no one wants to wait 6 minutes or whatever for a cluster to come. And then if I clear this, a nice new screen, and we'll clear this one as well. And then, yeah, so we're on the NAP demo UKS cluster. And if we do just a standard get nodes again on this one, we'll see a few more nodes. We've got the, well, actually, we've just got the free system node pools, but we've also got some extra labels. So if we check with this other long command, you can see here, I'm looking for the carpenter.sh node pool labels, and we can see these are virtual machine scale sets, and they're not Karpenter node pools, as you can see here, yeah? So these are just VMSS DS2 V2s, and then we can now go and watch for the Karpenter events. So we're doing the field select per sources Karpenter this time instead of cluster autoscaler, and we're doing a watch again. And then we are going to create the namespace inflate again, because it's a new cluster, so we need to recreate that. And then we will run the same manifest file in, which has 0 replicas, and this time we've got it nearly right. There we go. So yeah, that's now we got 0 pods again, so we can do kubec get pods, no pods again, and then we will scale that up to 10. To start scaling, and then if we go to get pods again, see them all in the pending state, and we can see that the events from Karpenter says inflate is the namespace, it's been nominated, the pod is the object, and it says the pod should schedule on node claim default -nm88c. We'll check this node claim in a second. But these are different logs to the cluster autoscaler, so it's something to keep an eye on when you're using NAP. And if we check again, still in the pending state, is it going to let me scale up this to the get nodes again? Those. So we just wait a little while to see if these will come through. While we wait for that, we will look at some of the resources that gets installed with Karpenter. So we talked about node pools in the cluster autoscaler, and we also mentioned node pools are not the same in Karpenter or in NAP, but we still have the name node pools, and these are basically like a CRD that are like a sort of a concept of a node pool inside AKS rather than inside Azure. It's inside AKS. So we have the default one and the system surge. So the system surge one is for your system node pool, and then the default one is one for every other resource you have inside your cluster. These are the ones that get installed by Azure as part of the add-on. If you're using the Helm method, you need to install these yourself. So if we let's just describe this default node pool, we can see here it's just a manifest file, a YAML file. It's got some labels here saying it's managed by Helm and we don't need to do anything with it. They're using FluxCD to deploy it for us as well, which is nice to see. It's got this node pool hash. These are just annotations that get added into it, and it's got the description: general purpose node pool for generic workloads. So you can create one of these yourself for, say, GPU workloads or burstable workloads and change bits and pieces. Don't edit this one because it will get re-updated by AKS when they do their reconciliation, because it needs to match. We're using Flux here, so if you make a change here, it's not in the Git repository, so it will get overwritten. This disruption budget is the cool bit, like to do with the rescheduling of it, sort of thing. So when the nodes are underutilized, it will consolidate and move things around and reschedule bits and stuff when it needs to. And this expires after, is set to never. What you can do here is actually say, right, I want a new node every 30 minutes or every hour or every 30 days. And you can set that here, so it will automatically refresh your nodes for you. So say you have, you shouldn't have, but you might have a legacy application that runs in a pod which fails like every day, and you want to sort of restart it. You could have a cron job that restarts it, or why not just start a whole new node and let it automatically restart for you right there and then. So you can do things like that. And then you just got the standard template inspect that you would normally see in like a Kubernetes manifest file. Here we're setting the requirements needed for Karpenter or the NAP, and we're saying the architecture needs to be AMD64. The OS needs to be Linux. The type needs to be on demand. You can have spot instances as well here. And then we have the SKU family. So this is D series. So we can have D, F, A, B, whatever VM SKU family you want. And then it'll go and look at all of those SKUs inside there. You can actually go further in here. There's extra values you can add to specify which SKU family, which SKU you want inside the family. So if you're using reservations, which probably most people are, or reserve capacity, and you have your reservation for a certain size of VM, you can actually say, right, Karpenter, I only want you to use this type of size because I've got reserve capacity, and then it will do that for you. And then it's telling me that it can have 16 CPUs of VMware storage, and it can have 110 pods. Hopefully at one stage we can actually change some of this, like the amount of pods you can run on a node, the kubelet configuration stuff, but we can't change that yet. You can in cluster autoscaler, but not here. It is super alpha, sort of not even beta really. So it's definitely in preview, not production ready just yet. And while we have a look at that, let's see if any new nodes have come. We've got one new node coming up already. As you can see, it's got a different node name. So this one was a node pool, which is your virtual machine scale set node pool. And this is the one that's using Karpenter. You can see it's still running the same Kubernetes version, but if we do an out wide, you may find that it's using a different kernel version or containerd version, but this time it's not. I've seen it a few times where it is using a different version. It doesn't cause any issues, but it's something to be aware of if you have something that relies on a kernel version, stuff like that. So if we look at here, we can see we've got some more events as well. So we can see these sort of unconsolidatable events. So we can't replace this new node with a cheaper node. So, that's also quite a cool feature. Instead of just trying to reschedule because the node's underutilized, it's doing it because it thinks it might be able to get you a cheaper node. So if I created a node pool resource, instead of using just a default one, and I created one for a B series VMs, B series are cheaper. Karpenter knows B series are cheaper because it talks to Azure. And if my B series, I have enough query in Azure, and the size I pick, say if I just put it down to one SKU, if I use the whole family, what Karpenter will do is just go off and look at those B series. After a bit of time, it'll say, this event here will say, right, I can find you a cheaper one. We're going to change you from the AKS default node to the AKS burstable node, which is the node pool I created to keep the cost down. So that's really cool. That's actually one of the really sort of compelling reasons for me to use Karpenter is trying to keep the cost down. What I'd also love to see, and which I think we might do, but I'm not 100% certain, is CO2 sustainability as well. So every VM has a cost. If Karpenter can link in with, say, the key to sustainability section and say, right, not just on cost, I'm going to scale you down, but I'm going to scale you down to this node because it runs here and it's using less CO2. Now, how cool is that? That's like, that would be amazing. Like, we need to start caring about the environment and stuff more than we are. And, yes, Azure is infinite scale and infinite resources, but it all comes at a cost, not just price, but CO2 and all that. So I would love to see that. Hopefully it comes, but if not, we'll put an issue in and we'll try and push them to do that, because I'm sure they can do that. They have the data there, so it should be able to be done. So that's cool. I like that one a lot. And then if we also look at another sort of new CRD type that gets created with Karpenter, is the AKS node classes. Again, we have the default and the system surge. So we're just going to look at the default one here. In fact, I have another command to save me typing that here. I'll put that as YAML. We can see here it's very similar to what you would normally see, except here this is just sort of like telling you a bit of information about the sort of nodes you can have. So we're seeing that it's using default node pool that we created, but we've got a bit more information in the spec. So here we're saying image family, we want Ubuntu 22.04. So, we're setting the OS version. Hopefully when Azure Linux and Windows, you can create a node class and it'll be Windows or Azure Linux, and we can set the OS disk size. Soon, hopefully this is where we'll like set the max pods per node and other bits and pieces. But we have these default ones out of the box, which is good enough to play with. But yeah, if you want to create a new one, you can do. And there's a lot more things you can put into here, which I have on my blog post. So I'm not going to go into all of those right now. You can check those on the Microsoft Docs as well. But these are the basic ones you get out of the out of the box, really. That makes it super easy to onboard. And then there's one more, and that is node claims. So if we look back at we keep saying it talks about node claims and stuff like that. So let's have a little look, see what these node claims are. So kubectl get node claims, and here we can see we've got a default the name of it, and look at this, a standard D16 AS. Because I had 10 pods, instead of doing what the other one did, so when we did cluster autoscaler, it had added 10 nodes because I had the CPU set to 1, and it means it couldn't have 2 pods per node, so it added 10 nodes. Karpenter's clever, it says, you want 10 nodes, I'm going to spin you up a D16 because that has enough capacity for all of your workloads that you just told me you want. So that's what it's done. It's in the UK South 1 zone, and this is the name of it. And we can actually output that as YAML as well and see what this looks like. And here we can see a long list of resources and stuff. So we can see the label is given. So CPU core 16, encryption at host is capable. It's a D series. It's got no GPU, the memory, all of these things you would normally see to do with the nodes. But then the node class reference is the default one, as we know. And then we've got some requirements. So we're saying, again, the SKU family needs to be D, needs to be the AMD 64, needs to be Linux, needs to be on demand, and the default. So we know all of that from the node pool, or all of this from the node pool. So it's added that into here. Then we know it's using the default node class, so that matches up there. And then it's gone off to Azure and got a list of all of the D series you have available to you on your subscription and in your tenant. So it's now gone through all of these machines that could potentially be used. As you can see, it's like mostly all the V4s, V5s, because that's what I have access to, and it's just picked the ones that it knows I could do. I'm just trying to see if it's got a D2 in there at all. So what I think it's done is just basically gone to the minimum size it knows it can do and then gone up from that. But so that, the D2S V2 is not even in there because it knows the D2S V2, there's not enough CPU needed on that, so it's not even going to bother with it, which is really cool. And then again, we got the pod size and the capacity and stuff like that. And that's NAP, which is really good. Node auto provision. So if we go to get nodes again, in fact, let's do the long one. It's in here. This one. We can see again, these ones are the virtual machine scale sets. And then this is the Karpenter node pool, and it's the default node pool. So if I had created one for the B series, I could call it B series. If I created one for GPU, I could call it GPU, and then it would say GPU here, which is really good. But I think that's been roughly 10 minutes now. So let me go back to the other cluster, and we'll see if nodes are scaled down. Yeah, so they start scaling down, and this last one is nearly scaled down. And then we're just going to have 3 nodes left like we had at the beginning. So Karpenter can be a lot quicker than Autoscaler. It's a lot more intuitive, like it's a lot more clever, basically. But if we go back to our slides, that one there, we're nearly finished. We should know about the limitations with Karpenter or NAP. So like I said before, it doesn't support Windows or Azure Linux. It can only be used on new clusters currently, so you can't update your existing cluster to use it. That feature will hopefully come soon. It's only currently supports Azure CNI overlay with Cilium data plane. Technically, it might support others, but they haven't done testing with that yet. So if you're going to test it out, make sure you've got that. I'm sure all the other options will come, so Azure CNI will probably come. It doesn't support private clusters either currently, but private clusters are your go-to secure WAF aligned type of cluster you need. So I'm sure it will be coming. And you can't do a stop and start with a NAP enabled cluster either. So if you're doing stuff in dev and you stop it at the weekend or in the evenings, then don't use this currently. Hopefully it will come, but we don't know just yet. And with that, I want to say thank you very much. And any questions?
Wow. 42 minutes just was
not bad. Yeah, it went very quick.
Oh man. Questions? Nothing in the chat. Philip did add some good points as well.
Nice. Thank you, Phil.
One of the major points for Philip is cluster autoscaler was not made for the cloud, where Karpenter is cloud aware, SKUs, zones, etc. Right,
yeah, so definitely. Because like cluster autoscaler was Kubernetes. Kubernetes was, it's on-prem to start off with and stuff like that. It wasn't really built with the cloud in mind. And yeah, Karpenter just rocks it. And I'm super excited to see that we finally got something like this in Azure. I'm so happy that Azure worked with AWS to get it open source, to get it donated to the CNCF. And yeah, it's definitely an exciting time for scaling your workloads in Azure using Karpenter.
Oh, and it's like not even an evolution, but maybe a revolution of the auto scaling capabilities, right? You mentioned Flux, and you went really fast, and you said, oh, Flux and this and that. Are you using Flux for your NAP demo cluster then? Is that
no? So when you enable the NAP auto provision add-on inside AKS, it's a managed add-on, and Azure themselves are using Flux to manage that on all of the clusters. I would love to see how it all works behind the scenes, but we can make this assumption basically because of the annotation saying it's managed by Flux. So it's like a Helm chart deployment using Flux from, I guess, a giant repository Azure has somewhere, which can, when you enable that feature onto your cluster or any of these add-ons, it uses Flux. It must create something in the Git repository to say, oh, go and push this to this cluster as well. And because it's using Flux, it uses GitOps. So if you make a change to these default settings inside the add-on, it will reconcile it. So it like constantly reconciles it. In fact, we might actually be able to see on the NAP cluster, if we do let me connect back up to that cluster quickly.
The first thing that comes to mind is that what will happen if I have Flux installed already without using the extension, right?
Yeah, so that should be absolutely fine, because it's like I think they must have, so it must be something to do with the control plane. But if you want to install Flux as well, you can. But I don't know how Azure works with AKS in the background, but they do some crazy cool magic, and I'd love to know one day. But I don't think they're ever going to tell us, even with our MVP status.
No, we can try again.
-a. Yeah, here we go. So we can see here we got the AKS managed Karpenter overlay and the overlay base, and we also have Cilium installed. So these are the charts. And you can see the revisions 49, 50, 49. And basically, these will keep going up constantly. I've seen clusters with thousands and thousands of revisions because like every 5 minutes, every 10 minutes, because of Flux, it's checking and reconciling with the massive Git repository that AKS has or Azure has. And if I make a change to one of these items here, then it's not going to be the same in the source control. So in the next revision, it will go and replace what I've changed. So don't make changes to the existing stuff. Yeah, there we go. Like it's just gone to 50 already. Don't make changes to the existing stuff. Create new resources, new CRDs. Just don't touch anything that gets automatically deployed with it because it will go away and you could potentially break things as well. Yeah. So
all right, makes more sense.
Pretty much all the add-ons nowadays are using Helm. So like if you do the monitoring add-on, it's basically a Helm chart that Azure manages for you. But it's really cool to see. I really would love to see how they do it all, but yeah, one can dream.
Yeah, who knows, man? Maybe you'll be on the other side one day. You don't know.
Right? if I am, then it'll be a secret that I would probably have to take to the grave.
Yeah. So you can, even if you would know, you can't tell anyone, right?
Yeah.
All right. I had another question. No, more of an observation about. I saw something yesterday, or the day before yesterday, regarding Weaveworks. Weaveworks is went belly up, right? So
yeah, which was a shame. Yeah, and obviously Flux is part of Weaveworks. You know, Weaveworks created Flux. Flux is an open source bit of software to do GitOps, and they have come out and said that Flux isn't going anywhere. One of the core maintainers has now got a job with Crossplane, which is another open source bit of software, and he's full-time still on Flux. So Flux isn't going anywhere, but it's a shame about Weaveworks. They create some really cool products. But yeah, these things happen, unfortunately, in technology. But at least we got the CNCF and the maintainers still caring about Flux, which is nice.
Yeah, because it was privately owned, closed source software, then there was a big chance that that it will just stop, right?
Yep.
Or somebody had to buy it or whatever. And now because it's open source and it's community maintained and it's CNCF, like you mentioned, then it just stays there, right? It's still maintained.
Yep. And then obviously if for some unknown reason something happened to Flux, which hopefully it never will because it's my favorite GitOps, we always have Argo CD. So in the CNCF, there's always options. We don't always like the options. Argo CD is actually quite nice, but I prefer Flux.
It's same here. I've been using Flux for a long time, and recently I started using Argo Workflows. We talked briefly about that in another live stream. And I'm actually installing that using Flux. So
hey, it works.
Yeah, absolutely. It's just another Helm, another Helm repository and a Helm release. Yeah, it works good. All right.
Yeah. Right. So yeah, I guess thanks everyone who has watched live.
Sorry. Philip keeps adding value. I tried to get him on stream, but he was not able to join, unfortunately. But next time. But yeah, it's control plane, not cross plane anyway. It's more detail.
No, I'm sure it's crossplane. Is it not crossplane.io? Anyway, it's they do infrastructure as code based on YAML. So you use your Kubernetes cluster to deploy your.
Right?
Yeah, I'm sure it's crossplane, and it will do some other crazy stuff. Unless he actually went to Crossplane, which is a different company to control plane. I don't know, but it's still being worked on. I know that much.
Yeah, that's the most important thing, right?
yeah, definitely.
All right, then. Yeah, I don't think if anyone doesn't have any questions. I ran out of questions. My mind's blown. It seems like it's a very interesting add-on to AKS in general, especially also the what was it? Cost awareness, and also then hopefully the environmental awareness as well.
Yep. Yeah. I really hope they do go down that route. I think it makes sense.
Yeah. Okay. So no.
Okay.
He's.
So it is control plane.
Yeah.
We should check that on Twitter or the. I think the Flux repo has a discussion, so I'll read that again. But that's good to know. Thanks, Phil.
All right, then yeah, let's wrap it up. Richard,
Awesome.
thanks. Been a pleasure as always.
Yeah, thanks for having me.
Yeah, anytime, man. So yeah, with that, Philip, thank you as well. He was almost here on stream, but then just through the chat.
We should definitely do something, the three of us, one day. I think it'll be quite a good, fun stream.
Yeah, I'm down.
Yep.
Yeah, let's set something up.
Sounds good. Awesome.
All right, then I'm gonna hit the end stream button. Thanks for watching. See you next time. Later.
Thanks. Bye.